All right, welcome back. Hononegah, Honors, Algebra 2, Section 2.1, Transformations of a Quadratic. So we want to talk a little bit, and we did this in, I think, the pre-chapter. We talked about a quadratic in vertex form. So it's got to be in this form as we are discussing this a little bit. And so a U-shaped graph for a quadratic is called a parabola. So this is a quadratic function. The a value, the h value, and the k value each does something different to the function. So when I put an a value in there, it causes a vertical stretch or shrink. When I put an h value in there, it causes a translation to the left or right. When I put a k value in there, it causes a translation up and down. And then when I change x, or if I multiply by a negative, again, reflections and stuff. So again, all of this causes something different. So let's go through this. If I want to translate something left or right, that is the h. Okay, so I'm going to draw an arrow here, the h value. So if I want something to go to the right, I would subtract the number from x. If I want something to go to the left, then I would add the number that I want it to go to the left. So a translation left or right is inside the parenthesis with x in a quadratic. If you want something to go up and down, you're going to take the function and add to the end of the function. So if you wanted it to go up, or a translation up, you would add the number that you want it to go up. If you want it to go down, you would subtract the number. So notice you're replacing the x squared with the parenthesis, and here you are just adding it to the end of the function. So there's a difference between replacing and adding. So here we go. Describe the transformation that is occurring here. So now, all I see is a parenthesis, and here's the original. A parenthesis x squared is now a parenthesis x plus 4. So that is a translation, and yes, you'll need to write the word translation. Translation. And it's a translation to the left, 4. And then outside I have a minus 1. So again, that is a translation. So you don't have to necessarily write it twice. So translation left 4 and a translation to down 1. So inside the parenthesis is the up and down. Outside the, let me try that again. Inside the parenthesis is the left and right. Outside the parenthesis is the up and down. Next, what happens if I want to do a reflection? If you take the entire function and multiply it by a negative, that is a reflection on the x-axis. If you replace the x with a negative x, that is a reflection on the y-axis. So again, whether or not you're going to do it to the entire function or whether or not you're going to just replace x. Okay, so those are reflections. Horizontal stretches and shrinks and vertical stretches and shrinks. I'm going to do the vertical one first. If you take the entire function and multiply it by a value, that is a vertical stretch or a vertical shrink. If the a value is greater than 1, it's a vertical stretch. If the a value is smaller than 1, that is a vertical shrink. Now, notice negatives means something different. So it's not going to be less than 1 and negative. So you're basically talking between 0 and 1 for a vertical shrink. Horizontal stretches and shrinks. You are replacing x. So notice the x is now an ax. So a horizontal stretch, and this gets confusing. If I want to do a horizontal stretch of 3, I am going to replace x with 1/3 x. This is an example. Okay, so it's the reciprocal that you're actually replacing for a horizontal stretch. For a horizontal shrink, again, if I want to do a shrink of a half, I'm going to replace x with 2x. So again, it's the opposite of what you might think in a horizontal stretch and shrink. So here we go. Describe the transformation. So here's the original. So what did they do? They put a negative sign. So they multiplied by a negative. That is a reflection on the x-axis. It's a half. They multiply the entire function by a half. That is a vertical shrink by a half. Notice they're replacing the x with 2x. So that is a horizontal, and now some of you are going to be confused by this, a horizontal shrink by a half. So if I am replacing x with 2x, that is a shrink. And then the plus 1 on the outside goes back to being a translation up 1. Now, they wanted me to go ahead and graph this. So let's say I made an XY chart. And I put in 0, I get 1. I put in a 1, I get 3. I put in a negative 1. Whoops, let me try that. 1, I get 5. Negative 1, I also get 5. 2, 2 times 2 is 4, squared would be 16, plus 1 would be 17. Negative 2 would also be 17. So I'm going to graph those. I'm going to make it in blue to make it a little better. 0, 1, 5, and there it is. Writing transformations of a quadratic function. So again, each one of those means something. So I want to make sure that the lowest point of the parabola is known as the vertex, and this is known as vertex form. So the h and the k are where the vertex would be located. A, depending on if it's whatever the number is, it's a vertical stretch or vertical shrink, and if it's negative, it's a reflection on the x-axis. So you're going to want to understand this page. So here we go. Let the graph of G be a vertical stretch of 2, a reflection on the x-axis, followed by 3 units down for f of x equals x squared. I'm going to write G. Do it in order. So if I want a vertical stretch of 2, I'm going to take this function and I'm going to multiply it by 2. I want a reflection on the x-axis. I'm going to take that function and I'm going to multiply it by negative 1. So that becomes negative 2x squared. Then I want to do a translation 3 units down. So I'm going to take this function and I'm going to subtract 3. So there is the new function for G. Now, graphing this function, I would just continue to do an XY chart. Those of you with graphing calculators, this is a good time to use a graphing calculator because there's a table function. I'm going to put 1 in. I'm going to get negative 5. I'm going to put 2 in. Negative 11. Negative 1. Remember, you're squaring, so negative 1 squared would be positive 1 times negative 2. Minus 3 would be negative 5 again, and negative 2 would be negative 11. So I'm going to graph this, and then I'm going to talk about it. See if I actually did this correctly. 0, negative 3, 1, negative 5, and then negative 11 goes off the graph. 0, here's the parent function. Let's compare. So the vertex got moved. There's a reflection, so that's why it's going down instead of up. The vertex was moved 3 units down, so the vertex of the new one is at 0, negative 3. And it's been stretched vertically by 2, meaning normally, and I'm just going to kind of circle this, normally this goes over 1 and up 1. Now it's going over 1 and down 2. So again, that's a shortcut method to graphing that I would probably do in person. That's a little more complicated to explain when you're not in person. So again, just a simple XY chart. Let the graph of the new function, translation 3 units to the right. I apologize, I was interrupted there, so this may become mid-sentence here. We're going to let the graph go 3 units to the right, 2 units up, followed by a reflection on the y-axis. So again, we have to do this in order. So if I have a situation that I'm going to write the G function, and I want it to go 3 units to the right, I need to replace the x's. So there's 2 x's in this case. I need to replace both x's with x minus 3. So again, moving something to the right is inside the parentheses. You're replacing the x with x minus 3. Now, if I want to go 2 units up, then I'm going to add 2 units to the entire function. So that is the 3 units to the right and 2 units up. Now, how do I do a reflection on the y-axis? I am going to replace the x's with negative x's. And so this would be my new function. Now I realize that's pretty ugly, and the graph of this would probably be, again, a little bit challenging and trying to figure out where the actual vertex would be. So I'm just going to not do the graph in this one, and I'm just going to write the rule. But you could easily plug some numbers in for x to try to graph it. The height h in feet of a water spray from a fire hose can be modeled by the function. And I'm going to pause this because the function is not there. Again, welcome back here. The function that we're looking for is h of x equals negative 0.03x squared plus x plus 25. And it is written in your notes. It just wasn't written on my page here. So where x is the horizontal distance from the fire truck, the crew raises the ladder so that the water hits the ground 10 feet further from the truck. Write the function that models the new path. Hint, find out where the water is currently hitting the ground. So here we go. We've got a hose and water's coming out and it's hitting the ground, and this is the function. This function, I want to know when does it hit the ground. So I want to know the 0. And I'm going to use a graphing calculator to actually come up with that amount. Like I want to know this hose, where is it actually hitting the ground? So again, I'm going to use a graphing calculator to calculate this. So here we go. Let's switch over to a graphing calculator. And I'm going to go to the y function, and I'm going to type this in. So I'm going to move this down here a little bit so I have it here. I can't see it, so there we go. Negative 0.03 x squared plus x plus 25. And so I'm going to hit graph. And I don't see the graph, so I'm going to change the window a little bit. So go to window, and I'm going to go 0 to 100. And then I'm going to keep it the Y max. I'm going to actually change to also 100. So go to your window setting on your graphing calculator and go ahead and now hit graph. And there's the water coming out of the water truck. And I want to know, where is the x-intercept? At what point is it crossing the x-axis? And so I'm going to hit second, calculate. And I want to know the 0. So again, I want to know, where is that crossing? Right there. It's crossing at, oops, graph. Sorry, calculate. It was there. I just did 0. Number 2. So it's crossing at 50, 0. Okay? So that is the point that it's crossing at. Now, I want it to go 10 feet further. So I'm going to raise my truck up so that it goes 10 feet further. So I want to know, what would it be when x is 60? Because that's how far then. So I'm going to go to calculate. And I want to calculate a value, and I want to calculate 60. And so I want to know, what would it take for it, if I wanted to go 60 feet, how much further would I have to raise it? And since it's at a minus 23, I would need to raise the graph by 23. So I'm going to close off this, and I'm going to actually put in what would happen if I added 23 to this equation. So my new function, my g function, I'm going to make a new one. Negative 0.03 x squared plus x plus 48. If I went to this function, what would happen? Okay, so I added 23. I went up. So I'm going to go back to my graphing calculator, and I'm going to go to y equals, and I'm going to go enter, and I'm going to hit my second one. So negative 0.03 x squared plus x plus 48, and then hit graph. I apologize. Hold on. Something went awry. Oh, I didn't type in negative 0.03. All right, let me go down here and see if I can fix it. Insert a negative. All right, now hit graph. So there's my original one. I want the water to go 10 feet further, so I raised it up, and now it should land 10 feet further. So hit second, calculate. I want to calculate the 0, and now I'm using the other curve. There. So I want to calculate the second curve, hit enter, and I'm going to arrow because there's a left bound, right bound. And there it is, 60, 0. So I have correctly raised my water cannon to find 10 feet further. So that can be a little bit challenging. It will not be on a test or a quiz. If you have any questions, your homework assignment then for section 2.1 will be out of the book. I see it's not here, but if you have any questions or concerns, please make sure you talk to your teacher.